So don't worry too much about it, because linear correlation and linear regression uses a lot of the principles that we've already studied in the initial chapters, plus a little bit of calculus and linear algebra. So you probably have already studied a little bit about what we're going to cover today, but from another angle. So you guys remember our good friend correlation? We have the ability to measure the strength of a linear relationship between two variables. There are some criteria or properties that correlation has. First of all, it is unitless. So like it's not 1 meters or 3 meters or so forth, but it's unitless. It's just 0.9. It ranges between -1 and 1. Closer to -1, it's a negative linear relationship. Closer to 1, it's a positive linear relationship. And if it's closer to 0, it's a very weak, either positive or negative linear relationship. So now that we have recalled what correlation is, I would like to ask you guys, do you remember how we can measure correlation? Do you remember what we can use to measure correlation? Anyone? Bagus said Pearson R. And we have one more friend. Yes, and Spearman Rowe. Great, guys. So yes, we have two ways to measure it. If I wanted to know about the correlation between X and Y, for example, I can measure it using these coefficients that you guys have mentioned in the chat. But if I just need to know a general idea about the relationship between the two, I could also use a scatter plot to get insight. So I'm going to show you some scatter plots just so you guys remember what it's supposed to look like. It looks like that, right? And from these scatter plots, you can infer a lot of things, maybe linearity, maybe how strong the correlation is. You wouldn't be able to get this, the exact score, but you can get an idea. And as you guys have already mentioned, if I want to know the exact score, then I need to compute the strength using either Pearson R or Spearman Rowe. So now that we know that this is how we can measure the relationship, so this particular scatter plot here shows a relationship between X and Y. When I'm talking about a correlation between X and Y, I treat both these variables as equals. I say that the sentence, oh, X is correlated to Y carries the same weight if I were to say Y is correlated to X. But I think I've already mentioned to you once before that please don't confuse correlation with causation, because that's a whole other thing. That is what we're trying to model with linear regression. So with a regression problem, we assume that one variable is the predictor, it's independent, in this case, X, and the other one is the outcome variable or the dependent variable, Y. So in other words, for every value of X, what is Y? So we've come out, a familiar face has come out here, linear regression. What does linear actually mean? So linear or can be approximated using a line. Please recall that this particular line can commonly be written as y equals mx plus c when we're talking about the context of variables x and y. And from this one, we know that that is the c and that is our m, our multiplier. Or the c is the intercept and that is the slope. So I think you should have covered this both in linear algebra as well as in calculus, in line equations. So I won't go that much into detail. I want to model this line, this so-called linearity, using statistical terms. So if you recall all of our material from the beginning, when I say, when I put it into the context of linear regression, I know something about X, and this helps me infer something about the variable Y. in this line, the line is what we are going to use to predict that value of y. So given x, I can predict y. Sound familiar? Given x, I can predict or I can get the value of y. Does that remind you of anything? Given x, we can have y. What is this? Oh, gradient. Is this a current comment? I'm sorry, Bagus, is this a current comment? There's no timestamp on it. Oh, okay. Not quite. That's not what I was looking for. So recall what we've studied before the midterm and everything. If you know x, then you can compute y. Given x, y. The value of y given x. Anyone else would like to try? Does that sound familiar to something we've studied before? I want to compute the value of y given x. I'll wait for a bit. Bagus has already come up with probability. Someone else want to complete that answer? What probability? It's a specific type of probability. Bias rule. Yes, that is the follow-up to that, but I'm not going that deep into it. The one right before bias rule, anyone? Anyone else? Don't worry. What does bias model? Something given something else, right? In other words, these are our conditional probabilities. We've already learned P of X given Y, P of Z given something else. So what's the probability of it raining given the sky is dark and so forth? We are modeling the same thing here. What is the value of Y given a certain value of X? So if I would reform this linear equation into something that is modeled statistically, then it's better off for me to model it the expected value of y given x. Don't worry, it's the same thing. It is a plus beta x. So it's still a multiplier of the gradient times the intercept. It's the exact same formula of the previous linear line equation. I'm just using statistical terms to model it. But I want you to please note that this is the line equation. This is the exact line equation. But obviously, when we're doing sampling, when we're using statistical data, there is some level of error that is added on to our estimation. So in order for us to be able to compute it using statistical terms, there are some assumptions that we are relying on. We rely on the assumption that the relationship between x and y is linear. Y is distributed normally at each value of x. So for any point on x, the y values are distributed normally, not the other way around. Please don't mix them up. And the variance of y at every value is also the same. So note here that the dependency is y depending on x, and each observation is independent. So now when we have x and y, we now need to estimate m and c if we are going to use the initial line equation, or in statistical terms, the alpha and the beta coefficient. So remember this line, we have the slope and we have the intercept. You must have encountered various ways where you can compute it. Please recall your linear algebra course, and you can also add some calculus in there. I'm very sure that you have covered this in your previous courses. But what you haven't covered is how to compute them using our statistical terms. So in the statistical term, using statistical terms, you can compute the slope, beta coefficient, using covariance and variance, as well as the intercept by elimination or by reversing the equation as follows. So as a short example, we have these lines. Please give me these points, sorry. Give me please the line equation through these points. Now this is the linear algebra solution. You use matrices, you use various linear equalities. So using this method, can I use it, Miss, if you have this question in your final later? Yes, you can use this method. You can use, this is, if I recall correctly, it's least squares problem. You may use this method if you find it the most easy for you. So this method is valid, but if you were to try and compute the same values of beta and alpha, in this case M and C, those two coefficients, those two unknowns can also be computed using our covariance formula using statistical terms. So as a conclusion, this linear regression is you trying to model a line using the statistical descriptive statistics that you are already supposed to be able to compute. So I have uploaded a more complete version of these slides on Scale, but you cannot access them yet pending something coming at the end of this lecture. I'd like to remind you that it's not, you don't have to use this covariance and variance method unless specifically asked of you. Like, for example, if the question is find the line using both the LSS as well as the covariance formula. But in the end, I personally think that you can utilize whatever pre-knowledge you have. So if you were to solve it using the linear algebra solution, that would be fine by me as well. So that brings us to the brief introduction. I'm on time, thankfully, about not additional, the supplementary kind of material that is the final material available in statistics and probability, linear regression. And for those that have just joined the session after I started, I already told the class that the reason that I chose to put this into your classes is because from my review of various curriculums of your partner universities, I believe that this is necessary for you to continue to more advanced courses. That's why I'm going to put it in, especially for the international class. Any questions? I'll give you about 2 minutes to maybe, I'll put this up again, maybe look at this newly presented material. And if there are any questions, go ahead. I'll wait about 2 minutes until 1:55, and then we'll go on to the exercise portion of this class. There is a question here for Abhimanyu. Can linear regression be used for other things than prediction? Like what? What would you like to use it for? I'm waiting for the follow-up answer from Abhimanyu. What would you like to use it for? But while I'm waiting, I'll go on to Bagus's question. So you can use, you can choose either LSS or covariance formula for the exam. You don't have to remember both. Let me correct you right there. You don't have to remember either of them because I do not believe in memorizing equations. So you can choose which one is easier for you if you have the information for both. But if you are given the information of the statistical ones, then maybe the covariance equation is more beneficial to use if perhaps you are given the variances instead of given the points themselves. But if you have both, if you have sufficient information to do either one, you are free to choose whichever one you prefer. Oh, okay. So Abhimanyu, I can't imagine, actually the question was only out of curiosity. Okay, instead of me making things up, let's just Google that together. Applications of linear regression. What can we use it to? It's, I must say that it's most commonly used for predicting trends. Used in businesses to evaluate trends, for forecasting and so forth. Because practically imagine that if you have, can I annotate here? Like for example, if you have, you know the information, the trend of this portion, then using the same principle of the same modeling, it's beneficial for you to estimate the continuance. And this is useful for, as written here, for forecasting, business decisions, and so forth.